Hello, my name is Kevin Day. This presentation is on Android operating system vulnerabilities. This presentation was part of my Vulnerability, Discovery, and Exploitation course at Metropolitan State University in St. Paul, Minnesota. This video presentation has been made available for informational and educational purposes only. Mobile devices have become the most prevalent method of accessing resources and services using the Internet. They collect and store personal identifiable information in a single location. This could be online identifiers, names, income, health information, and addresses. This is resulting in malware developers creating malware that targeting mobile applications. With the amount and different types of malware targeting these applications will only increase in the future. Detection of mobile application vulnerabilities remains a challenging mission due to the constant evolution methods used to obfuscate and evade existing detection and security solutions. Attackers will commonly exploit social engineering techniques to entice users. This could be from spam, phishing, false advertisement, drive-by downloads, attachments, and games. The Android operating system is a mobile operating system based on a modified version of the Linux kernel and other open source software. It's developed on top of the Linux kernel due to its robust driver model, efficient memory and process management, networking support for the core services. Android is free and open sourced, and its source code is managed by the Android Open Source Project, and it's primarily licensed under the Apache license. Apps and API framework is written in Java. The native code and shared libraries are written in C and C++. In May 2019, Android reached over 2.5 billion monthly active devices. Some history on Android itself. Android Inc. was founded with the initial intentions to develop an advanced operating system for digital cameras. Android was purchased by Google for approximately $50 million. In 2008, Android 1 came out, with the HTC Dream being the first commercially available Android device. In 2009, Android 1.5 Cupcake came out using Linux kernel 2.6. In 2011, Android 4 came out, titled Ice Cream Sandwich. This showed major upgrades to both the operating system and the user interface. In 2020, Android 11 came out. This new features included screen recorders, new permission controls, and one-time permissions. This increased the number of updatable core operating system components in Google Play. And in February of 2021, Google announced the development of Android 12. The Android security model is primarily based on a sandbox and permission mechanism. Each application is running in a specified Dalvik virtual machine with a unique user ID assigned to it. Application code runs in isolation from the code of all other applications. One application cannot grant access to other applications' files, and also operates under the least privilege principle, where each installed app is provided the minimal capabilities to guarantee its functionality, whereas the access to additional sensitive resources is limited by the grant of specific permissions. Google Play. Android application vulnerabilities have become a major problem because of the Google Play's open format and sideloading applications. Google Play does not verify uploaded applications manually. Google does discourage users from sideloading applications and third-party apps due to the security concerns, but installing from these other third-party markets are permitted. Some third-party apps are available through the official Google Play. Google Play does check third-party developers with Bouncer, a dynamic analysis sandbox environment used to prevent malware from entering the Google Play Store. And it's also capable of remote uninstall applications if the device is connected to the internet. Some vulnerabilities that are associated with the Android platform are remote access tools, which leveraging against mobile targets for intelligence collected by grant access to call history, address books, web browsing history, installed applications, short message servers, and multimedia message servers. It's used to send messages, enables cameras for spying and log GPS data. Crypto mining, where mobile devices can be used for crypto mining, leveraging Trojans hitting in legitimate-looking applications, which allow for the calculations to be performed on the mobile device to generate cryptocurrency. Mobile ransomware. Ransomware is malware that infects a device and then either encrypts or otherwise prevents the device from being used until a ransom is paid. The defining feature is a ransom is demanded by the attacker for the removal of the malware. It stays dormant, alternating the code in the background silently and setting a trigger for the user to activate. It uses encrypting data and demands extortion and money for data access, locking the phone or screen, thus functionalities cannot be used until the ransom is paid, and also stealing personal information or sensitive media files and threatening to disclose it in the public domain if they do not receive payment. There are two types of mobile ransomware, the first being the crypto, which encrypts important data, documents, and media content. Threat actors use cryptographic keys to lock and unlock the device, the data, demanding ransom in exchange for a decryption key. Locking, where the malware controls the entire user interface and locks the phone. The ransom stays on top of all other windows. The victim cannot delete the pop-ups or access anything on their device until they pay the ransom or have the right technological tools to get rid of the malware. Mobile Trojans are another problem within Android, where any type of malicious program is defined as a legitimate one, thus disguising to steal sensitive information such as login credentials, account information, financial information, and credit card information. Disguised as legitimate applications, they lure users into installing the application on their mobile device, hiding from both users and antivirus protection and achieving persistence on the target device for operating seamlessly. Some mobile Trojan detection evasion methods include dormant capabilities, hiding components in other files, formatting part of a rootkit, or heavy obfuscation. Mobile banking Trojans are developed with the final goal to compromise mobile banking credentials. Criminals will have total access to account features such as funds transfers and bills payment. Once the banking application is launched, the Trojan will display its own interface in an overlay, the banking application's interface, such as an overlay attack. It launches a duplicate user interface mirrored from the banking application layered on top of the actual bank's user interface. The user will enter their credentials into the counterfeit UI. Then the Trojan will begin to steal their credentials to steal the money out of the victim's bank account. The different security solutions available to the Android platform are operating system enhancements, where enhancements at the operating system level must be made to prevent and detect malware infection, increasing the built-in capabilities to ensure compliance, and so end users are not required to install or manage third-party applications or certifications. Once a user has installed a piece of malware on Android, the OS should be responsible for providing the following basic security protections. Isolation between processes, restricting access to the files on the file system, limit operating system support for an overlay attack. Also, being aware of malicious email attachments. Mobile users should be aware not to click, download, or open suspicious emails. Users should only be aware and take preventative measures before you download files. Only download files from a reputable source and site. Also, software updates. Only downloading applications and updates from the official Google Store, such as the Google Play. Users can ensure the latest version of your Android operating system by checking the system settings. Device protection methods. Installing an antivirus solution for Android, such as Kaspersky Mobile Antivirus. Most antivirus software will ask if you want to scan a file for malicious intent before downloading the file. As an extra step, device users can run an antivirus scan after downloading a file to ensure that nothing malicious has slipped through the cracks. Developers implement a strong authentication scheme. device remains secure even when subject to a mobile or smart card attack. And also the new detection methodology implemented based on machine learning techniques such as clustering methodology, deep neural networks, and the generality of samples to train the machine learning models. There are two main analysis methods for malware analysis. The first being static, which is the process of analyzing code structure of the sample to determine its functionality. The sample itself is not run. Instead, it gets a fingerprint of the hardware, such as a hash. However, the preliminary conclusions about the sample cannot be determined. Next step is often the dynamic analysis, where the sample is actually run within a device or simulated environment. This determines how the sample responds when the data or is executed within an environment. They'll be looking for such things such as process management or network monitoring to see what kind of traffic it generates and what ports it's using. On-device analysis limitations. The limitations being cannot be directly scanned to other applications' memory, files, read-write privileges during. Android permits execution of background application services, stopping anti-malware application services if it runs out of hardware resources. Privileged applications can force stop an anti-malware execution with the correct privileges. However, without root privilege, an antivirus service cannot create system hooks to monitor the file and/or uninstall malicious applications. These are the references I used for this presentation. Thank you, and I hope you enjoyed it.